This PowerPoint goes through the first part of Chapter 2, Section 2.1, describing particularly where a data value falls in the in a particular distribution. So we're looking at describing a data value's location in a particular distribution. We'll start with Notes 2.1, Day 1 handout, labeled as Cumulative Relative Frequency Graphs. All right, so here's this first handout. It really looks more like a worksheet rather than a PowerPoint slide note handouts. So what we're looking at is the data for the ages at presidents' inaugurations. So we've had 46 different presidents. And for example, if we look at this data in the table, there have been 2 presidents who have been aged 40 up to, but not including 45. So 2 that are older than 40, but have not reached their 45th birthday. And then there are 7 who are at least 45, but have not reached their 50th birthday, and so on. For a total, as you see in the bottom, of 46 presidents. Okay, so what we want to first do is look at relative frequency. So you can see the first relative frequency for those aged 40 to 45 is 0.043. So we can think of that as a decimal, or we can think of that as 4.3%. Kind of up to you how you want to do it. I'm going to leave them all as decimals. So that means that instead of saying the frequency of presidents aged 40 up to 45 is 2, now we can say that the percent of presidents who were aged 40 to 45 was 4.3%. So the relative frequency is just the percentage. And we calculate that by just simply saying for that particular first class, we would say there are 2 of them divided by 46. And that would give us this 4.3%. Or like I said, I'm going to leave it as a decimal, 0.043. So continue, continue calculating the rest of those relative frequencies. All right, you can see here I've already calculated them all, and so they're on my table. Either pause this video while you calculate those, or just double check that yours are the same as mine. All right, so the next thing we'll talk about is the cumulative frequency. See, the cumulative frequency is sort of a running total. So it's for the very first class, 40 to 45, it's just the same, right? There are 2, in other words, there are 2 presidents younger than 45. So the next one we want to think about is how many presidents are under 50. So you can see that there are 9 presidents under the age of 50. So we're simply doing a running total. So 2 plus 7 is 9. The next one we'll do is we'll add 13, the next value, to the previous total of 9. So you can see we have presidents, the number of presidents that were under age 55 was 22. And we can continue this process for the rest of them. Also for this, this column, it doesn't make sense to total these up. That last number, 46, is sort of already a total, all right, because this is a running total or a cumulative frequency. Now, more often than not, we don't really graph cumulative frequencies, but we do cumulative relative frequencies. So we want to do a running total not of the frequency, but of the relative frequencies, so percentages. So you can see here that, the first, just like the cumulative frequency for the first class was the same as just that one class's relative frequency. There are 4.3% of the presidents were younger than 45. We can calculate the next one, you can see, by simply adding the 4.3% with the 15.2% in the next class, giving us a total of 19.6%. Another way that you could do this, rather than adding up the relative frequencies or creating a running total with the relative frequencies, is you could take the cumulative frequencies and divide those by 46. So 9 divided by that 46 would also give us that 19.6. So you can do like a running total of frequencies, or just kind of start over. So this next one would be 22 divided by 46. All right, and then so you can kind of see what the rest of them are. At the total at the bottom, again, it's a running total, so it doesn't make sense to add up that column. The last row there should be a 1. So that means 100% of the presidents so far at their first inauguration were younger than 80 years old. Okay, so now we want to use those relative frequencies. So set aside the cumulative stuff for a minute. Create a histogram with the relative frequency. So first thing we want to do is come up with scales. I made the scales pretty nice here so that you could go by 5% on the bottom. So starting at 40 and then going all the way over to 80%, and then up the side, each of those tick marks I think works well if we use 100%. Now we don't need 100% if you look at the relative frequencies or the percentages. I think my highest percentage was like a 28.3%. So we wouldn't really need to go up to 100% on our vertical scale if we were just doing a histogram. But we want to do a histogram, and then on top of that, we're going to do this new graph called the cumulative relative frequency graph. So we do need that to go up to 100. Okay, so let's look at what would probably be good. And also we need to label our axes. So you can see this kind of works well. Like I said, starting at 40, going all the way over to 80. Each tick mark is another 5%, age 5 years, 5 years. And then the tick marks on the vertical, each of those tick marks is 10%, but I just labeled them every other one. So, and then relative frequency on the vertical axis and age, and then also a nice title for our graph would be good. Age at inauguration of the first 46 US presidents. Okay. So now let's create a histogram. So look at your relative frequencies. The relative frequency is simply going to tell us the height of each of our bars in our histogram. And you can see it's slightly skewed right, mainly because of our last two presidents. Before President Trump, the graph would have been fairly symmetrical, but Trump and Biden were rather old, and so they sort of now make this thing skewed to the right. Okay, so now we want to look at creating a cumulative relative frequency graph. So now we want to look at the sort of that last column to help us guide where we're going to put, and we're really going to put dots. So we start with a dot at the far left value of 40, and that's going to be a 0 because there are 0 presidents younger than 40%. All right, so I put a dot there. 40 comma 0 represents the fact that 0 presidents are younger than 40 years old. And then if we go down the column for the cumulative relative frequencies, the next one is 4.3%, and it just happens to be this one happens to be the same as the relative frequency for that first class. And then they start diverging. The next one is about 19.6 or almost 20%. So we put a dot at the 50 comma 19.6%. So that means that about 19.6, almost 20% of the presidents are younger than 50 years old. And we just continue going down, putting dots for each of the corresponding right-hand boundaries for each of the classes. All right, and so finally at the end, the 80, right, at a year 80, we're up at 100 because 100% of the presidents are younger than that age. So we're going to be able to use these things to talk about percentiles. So for example, if you did better on your SAT score than 90% of the population who took it, then you would be at the 90th, what did I say, 90th? 90th percentile if you did better than 90%. So 90th percentile, and so that's what we're going to start kind of using here is we're going to talk about percentiles from this cumulative relative frequency graph. Now, the last thing we want to do is simply connect each of those dots with a straight line. All right. And depending on how accurate your lines are and where your points are, this will be a little bit easier to use. All right, so at the bottom of this page, there are a couple of questions. So number 4 says, the cumulative relative frequency graph allows us to ask some interesting questions. All right, so the first question, A. Barack Obama was 47 when he took office. Is this unusually young? So in other words, where does that fall in the distribution? So if we look at running 46, we go up the age 47 and we see where it hits our graph, and then we go over and read off the percentage. You can see that that's about 15%. So that means 15% of the presidents, only 15% are younger than him. So yes, this is a particularly young. He is particularly young because his percentile is 15%. All right, question B is 65% of our presidents were younger than what age? So in this point, we don't want to go up from the age. Instead, we want to go over from 65%. And we read off what that corresponds to, where it hits the graph, and then we go down, we read that off. Seems like that's probably about 58 years, okay? Somewhere between 58, 59, but probably closer to 58. There's a little bit of leeway, depending on how well you create your graph. If I'm asking you to interpret these on a quiz or test, I'd probably give you the graph so that it's not kind of dependent on how good or bad your graphing skills are. All right, question C. Martin Van Buren was 54 years old. What percent of presidents were younger than that? In other words, we're asking what is Martin Van Buren's percentile? So we go up from 54, and then we take that, hit the graph, and go over. And so I would say, looks something like 42, maybe 43%. So his percentile is 42, 43%. Not particularly young compared to the rest of the presidents, but there were about 42 or 43% of the presidents were younger than him. Okay, so now we're switching over to the actual notes that are the slides, printouts of the slide presentation. We're just going to practice a little bit more percentiles. We've talked about percentiles and how we can use those with a cumulative relative frequency graph, and we'll revisit that graph we just made in a minute for some more practice. But here, just talking about percentiles in general, you can use percentiles with other graphs and other and tables or whatever without using the cumulative relative frequency. So the percentile is simply if you're the pth percentile, then that means you have p% of your observations less than the data value you're looking at. So let's look at an example. So Jenny has a score of 86 on her test. How did she do compared to the rest of the class? Like, what is her percentile? So we can see where Jenny is on this STEM plot, 86. So she's sort of towards the top. So she did pretty well. This graph shows us that the data is fairly symmetrical as well. Let's see. So according to the rule, we want to know what percent of the people did worse than her. So we need to know how many people are in her class. We could count how many leaves there are, and you would see there are 25 leaves. And then count the number of leaves below her, right? People that did worse than her. And there were 21. So we would look at her score is greater than 21 of the 25 data values, and so that would correspond to a percentile of 84%. All right, so she's in the 84th percentile. She did better than 84% of her classmates. Okay, now these percentiles are sort of estimates. They really work better when you are dealing with large sets of data, like the PSAT, for example. All right, so they're sort of a little bit of an estimate, because if you think about it, if you are the top score, there's 25 people, right? So if you had the top score, you'd have a percentile. You did better than 96% of the other people. So even though you had the top score, you're not at 100%, but that's because our data set is rather small. This works better when you have 100,000 data values, like when people take the PSAT or the SAT or the ACT. There's hundreds of thousands of data values because there's hundreds of thousands of people who took those tests. And so you're at the top score, you're at the 99.9999 percentile. So essentially you're at the 100th percentile. You did better than 100% of the people, but you can't do better than yourself, so you're part of that 100. So the numbers are a little bit of an estimate sometimes. With smaller data sets, they sort of seem a little wacky, but just know that the rule is that the percentile is the percent of people who did worse than you or are below the data value in a particular situation. All right, so here we can revisit our cumulative relative frequency graph. Sort of already have all these numbers. You already have this graph. If you want to look at this next slide, or if you want to look at the original graph that we made on the worksheet, either one you can use, but this is a pretty good graph. Depending on how well you did making your graph, you might want to look at the slide. The next slide has the graph on it. Okay, so here again is our graph, our cumulative relative frequency graph, and we're going to ask some questions about the graph. So we already asked a couple questions, let's ask some more. So what percent of presidents are younger than 50 years old? Okay, so you can see we go up we start at the bottom, go up from 50, hit the graph, go over and read that, and it's about 20%. In reality, the data from our table would tell us it's 19.6. So, I mean, that happens to be an exact value because that is one of the endpoints of one of our classes, but about 20% there. All right, next question. Approximate Q1 and Q3. So Q1, think of a box plot. Think about what fraction of the data is to the left of Q1. And so you would hopefully remember that 1/4 of the data is to the left of Q1. And so if 1/4 of the data is to the left, that means that Q1 would be the 25th percentile. So we want to start over at 25% and go over to the graph and then read off the age that comes down from there. So about 51 years old. And then Q3, same kind of thing. Q3 on the box plot is the value where 3/4 of the data is to the left. So that means that would sound like a 75th percentile. So you read off 75, see where that hits the graph. And it's about 60, maybe a little bit bigger than 60. If you said 61, that's fine too. So we could also ask, what's the interquartile range here too? And you would just subtract the two numbers that you got. Here I got 9. If you did your Q3 at 61, then your IQR might be 10. Remember that those squiggly equal signs mean approximately equal. All right, so it's a way of saying about 51 years of age. Okay, the third question, approximate the age under which 60% of the presidents were inaugurated. All right, so we're going to take our our graph over to 60%, right? Start at 60% on the vertical axis, go over, hit our graph, and then read down. And that's about 57. I think maybe if you said 58, that'd probably be okay too. Okay. All right, the next question is, how could we use this graph to create the histogram? Now we kind of have to estimate it because we don't have the exact values here, but if we had just this graph, how could we create the histogram? So think about what the first bar height would be. Remember, the relative frequency and cumulative relative frequencies are the same value. So the first bar would just be where that first non-zero dot would be. The second one, think about where that would be. Well, I think if you think about it, you'd realize that it is the difference in those heights. So for each of the bars, these would be the heights of all of our histograms. And then, of course, we don't want them like that. We would bring them all down. And so that would be our histogram. And you can see that is the histogram that you had created on your worksheet at the beginning of these notes. Okay. All right. One other way to talk about your position or a data value's position in a distribution is to look at the z-score. The z-score is simply the data value minus the mean of the whole distribution divided by the standard deviation of the distribution. So that z tells us how many standard deviations above the mean you are. So let's look at an example. Let's go back to Jenny's example. And so we didn't give you this information before, but now we're telling you that the mean of the test score, the mean test score of her class was 80, and the standard deviation of her, remember, standard deviation is a measure of spread. It's how, it's the typical difference between the scores in her class and the mean in her class, right? So the standard deviation for her class was 6.07. We want to know what is her standardized z-score. All right, so it's just her value minus the mean, and then we divide that by 6.07. That gives us about 0.99. That is not, remember, this is not a percentile. She's not at the 90th percentile. That 0.99 is close to 1. That means her test score is just shy of 1 standard deviation above the mean. So you can kind of see that, right? She's 86. She's at 86 here. The standard deviation is 6 above the standard deviation is 6, and that's just about 6 above the mean, which is 80. So she's right at 1 standard deviation above the mean. All right, let's look at another example for z-scores. Jorge is in Mr. Rogers' trig calc class, and Santi has Mr. Rubin. Both teachers gave their own Chapter 4 test to their own class. Mr. Rogers' class's mean score was a 75% with a standard deviation of 4.7%. Mr. Rubin's mean was 65% with a standard deviation of 6.2%. So that means Mr. Rubin's scores were more spread out than Mr. Rogers' scores because his standard deviation was larger. All right, so Jorge, who was in Mr. Rogers' class, got an 84%, and Sante, who was in Mr. Rubin's class, got a 79%. So compare each of those two students' scores to their own classmates. Who did better? Now, clearly, Jorge got an 84, and Santi got a 79, but relatively speaking to their own classmates in their own classes, who did better? And so what we want to do here is look at z-scores. So calculate each of their z-scores. Okay, so you can see that Jorge's z-score is 1.91, so that means just a little shy of 2 standard deviations above his class's mean. If we do the same thing for Santi, we see that his z-score is 2.26, so he did about 2.25 standard deviations above. So even though Jorge's score, ultimately 84, is better than a 79, Jorge did not do as well relative to his own class as Santi did relative to his class.
So Santi scored more than 2 standard deviations above his class mean, whereas Jorge scored less than 2 standard deviations above his mean. So clearly Santi did better when you compare them to their relative classmates.
All right, so the first part, the homework for the first part of section 2.1 is the following. So after the first day of going through notes, work on numbers 2, 3, 5, 9, 15, and 16. That would be due for next class.